Hi, everyone. So I'm taking a look at the average rate of change, growth and decay characteristics, Desmos activity that I asked you guys to do after you finished the paper activity to double check that you were understanding everything. As you can see, a number of you logged in and didn't actually do anything. And one person actually tried all of the questions. So this is really going to be hard for you guys to get the understanding you need to if you're not engaging and doing the Desmos activities, because that's my way of checking to see if you're understanding some of what we're doing. So just be aware of that. You do want to log in and do those activities. If we look here, we can see that the first one was asking you to calculate some average rates of change. And when we look, we should see that the average rate of change in each of these cases, and notice you can click on this and see the values of the points here if you want to. So I go from an x value of 1 to an x value of 3, and my y value goes from 5 to 13. So that's a change of 2 in my x value and a change of 8 in my y value. So my rate of change is going to be 8 divided by 2 in that case. So it's going to be 4. So this answer here, the average rate of change between all of the points is 4, is correct. You have to be careful. That first one is not equal to 8. It is equal to 4. If we look at the next one, we calculate the average rates of change. You're not going to see constant rate of change like we did in the last situation because we do not have a linear function here. This function is the square root of x. And what you will see is that the rate of change will decrease each time. So if you calculate the rates of change here, you should see a decreasing rate of change on this one. So notice I've anonymized all the names, so you won't be seeing your name here. Be careful with that. The rate of change here is not increasing. The rate of change is actually decreasing. And if we calculate that, we can see it. So let me just pop over to Desmos for a minute and you can see that. So go on here. If we have f of x is equal to the square root of x, and so now we can say that we had so our first rate of change that we wanted to calculate was between 0 and 2, and f of 2 minus f of 0, and then we would divide it by 2 minus 0, and our rate of change will be 0.707. And then our next rate of change that we wanted to calculate was between 2 and 4. So we will take f of 2 minus f of 4 minus f of 2. You can do it either way, but this is probably the way you would have done it. Over 4 minus 2. And you can see on that one that our rate of change is down to 0.292. And then if you did the next one, you would see it decreases again. And that makes sense because early on, that increase, when I step over 2, I'm increasing by this much, right? So my rate of change is this divided by 2. But when I go from 2 to 4, I'm only increasing by this much, right? This little line here. Because I go here, I'm here at 2. So when I come over to 4, I'm increasing by just that much there. So the rate of change is decreasing. And then if you look at these guys, these are just statements about the concave up functions or concave down function. The only statement that's true here is that the rate of change for our concave up function is always increasing. None of the other statements are true. And similarly here, the only statement that's true here is that the rate of change for concave down function is always decreasing. None of the other statements are true. On this one, if we can click on the answer key to see here. The rate of change for a linear function is always constant. A function which has a rate of change of 0 everywhere is linear. It is constant, so that's one that's easy to miss. A function which has a rate of change of -3 everywhere is linear. And a horizontal line is a linear function. That is definitely true, whereas a vertical line is not. Increasing linear functions always have a positive rate of change. Decreasing linear functions always have a negative rate of change. And a function with a rate of change of -5 everywhere is a decreasing linear function. And notice that this graph down here, which is quite small, but is not a linear function. So although it's made up of two lines, because the rate of change goes from being negative to positive, that is not a constant rate of change, and so that is not a linear function. Okay, so I definitely recommend that you guys log into Desmos and really try these Desmos activities yourself before I'm giving you feedback on them, because that is a good way for you to see how you're doing on these concepts. Okay, I hope everything's going well with the linear equations activity, which is due tonight, and I will be online at 2 o'clock if anyone has questions. It's Tuesday, so we'll have our Tuesday meeting at 2 o'clock. All right, guys, I'll see you later.